so good. Good coffee this morning. Just getting going. Got a little chill up on. I'm going to turn that off in a bit. We are going to do some more Go code this morning. On this beautiful Sunday morning. I was going to do some writing, but I stayed up a little bit late watching stuff. I've been watching The Money Heist. You guys know about that? It's a pretty good one. So we're going to pick up where we left off. And I'll go ahead and drop this. So we've been doing a bunch of stuff with the with this Go configuration. We finished the map yesterday morning. We finished the map structure yesterday. So I think we got it all tested too. We did set, get, save. So this is we need to do save. Okay, so we created we created a map structure that's an internal key value pair map. It's an encapsulated map structure with an added read write mutex, so that things can deal with it concurrently in the same memory namespace. And we made a constructor-ish kind of function. It hands off a pointer to one. It has to be a pointer because this is a struct, and you wouldn't use the right one if we didn't do that. It would make a new one every time. We've got, what else we got? We got our stringers and our JSON converter. I'm not going to do YAML because that would add an external dependency, and I don't want to do that. And you can convert the JSON to YAML, no problem. That's no problem. We added the error. That's actually not valid JSON. That's a good catch there. Okay. This is an impossible one to test, so this is a tough one. Well, actually, not really. We could probably test it right now. We could just do. Here, let me try something. I want to test to see what that actually is going to print out. So we're going to add a new one. I'm going to do a JSON call. Got byte declare, but I use map line 76. Yep. All right. So let's do that. We're gonna throw that out for just a second. I just want to see what we get. Yeah. Okay. So we get the error and the nil because there is no value. There was no actual error generated. We had to make it up. So I mean, this is a tough one to test. We can't really test it because it's not. This is actually a tough part about testing. Is there's some cases that are generated by the standard library that almost never happen, and it's going to leave that part of the code uncovered because you just can't get to it. You'd have to force a bug in the parent, dependency or the whatever. So we're not going to do that. So we've got JSON code there. So this map thing is done. We just need save. Save is the big one. We need save and load actually. Let's do another one. Let's make a scaffold for load. And load will take a string path. I don't know, man. We could do read. I could do read or load. We should probably do save and read. Read means it can be read from any file descriptor. That's probably what we should do. I mean, I don't know how flexible to make this thing. I think load should imply the location. That's what I think. And I think read should take a file descriptor. All right, so read the implied exe file values. So, and and then we could have read, and we'll just make read take any files, take any reader. So there's a thing in Go called I forget what it's called. I use it every day, and now I can't remember. It's in the morning. It's called a read. It's not a read write. It's an IO reader, of course. God damn it! Took a drink of coffee to get there. Good morning, Darun. So we're gonna do this. We're gonna do read. And I'm just gonna say source. And we're going to take an IO reader. So anything that fulfills the IO reader interface. This is the magic of interfaces. Okay, so people, they think that Go is limiting because of the types and everything. But the thing that makes this nice, how's it going, Awesome? Ptolemaic, is that the IO reader interface can be anything. Anything that implements the IO reader interface can be passed in. Anything at all, as long as it fulfills the interface. And this is, part of the solid principles that people talk about with Java and stuff and OOP. Because anything that fulfills the interface can be passed as an argument. It's actually treated as a type, even though it's, strictly speaking, it's not a type. The type is, I have these methods, the end. And that's why people tell you in Go and other languages to make sure that your interfaces are small, right? So, like if I wanted to do this map differently, and make it so that it could be read more easily, I could break the interface down, and people do, So it's like you can have a conf get interface, a set, a raw, and load and write. But I'm going to put them all in here because this is something that I want it to be able to fill. So people would say something like a getter or a setter, right? And then they would add both of those to a parent interface. And then so if anything that implements a get method at all can be passed in. Some people would argue that this is bad because I'm putting so many methods in there. But this is mostly just for compatibility. I want people to be able to re-implement what I'm doing here. If they don't have it, if they don't have this, they don't have everything. I could make it though, so that, if I wanted to get really crazy, I could have type getter, right? So a conf getter, and maybe I should do this. I don't know. This is an architectural decision. How's it going? So if you come in here and you do getter and you say, I have a getter interface, and all you have to say is, I have a get method, right? So this is actually one way to do this. This is, the way, and then you can compose your interface. This is kind of cool. So you can say, you can do the embeds. You can say a map interface has a getter, and it has a this and a this and a this and a this. And some people think this is overkill. I have mixed feelings on it. It has to have a getter, and it has to fulfill the setter interface, right? But other than that, it doesn't need to do anything. I might as well go ahead and do it. It's not going to hurt anybody to do this. So just a little bit of documentation is all. So I'm creating a bunch of interfaces. The conf.getter, the conf.setter, and this is idiomatic. I know it seems weird, but it's the way you do it. So a type. So what I'm trying to say is that you could pass any object into that, and it will work, right? So I could do conf.type reader. So conf reader takes an IO reader, and I could actually, if I wanted to, I could implement the reader interface itself. That might be the thing to do. If I did that, then my thing would fulfill the IO reader interface, and therefore it could be used anywhere an IO reader is used. So I know you guys know how double stars are going, Black Mouse. You guys realize I'm kind of digging deep here, but these are the kind of things, if you're going to have like a really long running thing, you might want to look at. It's because it feels more complicated than anything. It feels like people making Python classes with only one init method. Yeah, but it does serve a purpose. Let me show you. So if I go, it's all over in the standard library for a good reason. So if I do Golang, let's do Golang FMT. So the FMT package has a stringer. Excuse me, I'm kind of just woke up here, so here, a type stringer. A stringer is implemented by any value that has a string method. There it is. See that? That's it. And that's so the reason they make it that way is so that it's sort of polymorphism. So it's kind of like you want to allow your thing to be passed into as many possible other things without being punting and being an untyped interface or a generic or something. And the way you do this with interfaces, if you do interfaces right, and if you make interfaces smaller, Pike comes straight up and says you should only use one. And it makes sense, why not? But if it's just so people don't complain about 5-method interfaces, it's not amazing. No, that's not a reason. I mean, the reason is for passing. So you want to be able to pass. The reason is so that you have the highest compatibility with more things, right? So somebody else might want to implement something that uses your, that can be passed into your thing. And the way to do that is to make it the most flexible as possible without dropping the type, right? And unless you're using a primitive type or structure, it's also the reason you shouldn't pass in structures. This is bad practice in Go. You can do it. I mean, there's exceptions, obviously, but the general idiomatic rule in Go is pass interfaces, return structures. And those structures can implement interfaces, but you return the structure so you have more flexibility. You can do what you want with it. So, and the reason for that is to give you that, that flexibility, not as much flexibility as like Python where you can pass anything in you want. So, map string interface leads to hell. Oh, yeah. Wait, yes, it does. So then we have, and there's a scanner. Let's go look at a scanner. So a scanner has a scan interface, right? It's called the untyped interface, or the empty interface. That's what it's called. It's the one you're talking about. Interface with the yeah. So let's take. I want to take reader. I'm going to look at the IO reader, because I think I might be able to fulfill the IO reader without making my own conf reader. If I can fulfill, this is another thing about Go. If I can make my thing fulfill one of the standard Go interfaces, I just made my thing usable with that many more things that are already documented and already used. So this is taking extra time. It's a stupid little conf module, right? But this research about making compatible and stuff pays off in the end with compatibility and usability. JSON schema to protobuf. Ugh. Yeah. Package IO provides basic interfaces. So in order to do this, I'm going to go look at the reader interface, and we're going to go see how much I have to have. So there's lots and lots of readers. They have a limited reader, multi-reader, T-reader. Ooh, that's cool. Reader at, read from. These are all interfaces. So the only thing I have to fulfill, so this is the reason I'm looking at this, is I actually just learned something. Remember I said I was going to make a read method, right? So by looking up the IO reader, rather than having my reader take an IO reader, I now have this, right? I can if I fulfill this, I fulfill the IO reader interface, right? Now I can do that, and just have it be a thing. I can actually have 2 read interfaces. I don't know though if I want to do this one. This one is passing like an actual summary of bytes, so it's not as convenient. I don't know if I want to do that because this isn't as convenient, right? The point here is convenience for the end user, and we want them to be able to pass in. We want them to be able to pass in any IO reader. I mean, the whole point here is that we want them to have the multiple flexibility in calling it. and IO reader has always been defined. So I'm going to go stick with my reader here. So we're going to say, R, and then let's say IO.reader. So any IO reader, and then that will return an error. And that's actually good for testing too, because I can actually set up the IO reader. I can do a string reader, and I don't have to read from a file. I can test this method without having to do that. So what else we got? Well, we're going to come over here. So now I have a setter. Raw. I don't know what raw is. Raw gets to the internal thing, right? So raw doesn't make sense to implement as an interface. That's stupid. So first of all, that should be returning. I don't know what the fuck that's doing. Raw is returning the map. It's not passing it. I don't know why I did that. Yeah, we don't. Yeah, that's what it should be. It should be returning it. Hi.
Hi.
How are you?
Good. I was just wondering if you'd borrow my nice black pens that you hate, but I love.
Probably if I did on accident, maybe.
No, there's like a.
I haven't picked any pencils or pens up in the last week.
And I haven't found like they've been missing a while, so I'm like.
I don't know. I have to clean to get it. All right. So where are we? Okay. So map string interface. We could have a getter. We have a reader. We could have a saver. I mean, this is why it's so weird, right? I don't know that this is better. Some people would believe this is better than others. So, saver, believer. So I'll have save, and we'll save and load. See, here's where you get really crazy. I mean, you could do this. You could do type persistent, conf persistent, and then, I mean, I'm just showing you. I might not actually keep all this. I just want to show you. You could have a saver and a loader, and then down here, you could have this. You could have mutator. Technically speaking, the getter is not a mutator, but you could have a mutator and you can combine these two as well. So, I mean, you can get really nuts with it because, and that it just opens up a bunch of stuff. You have to support all that. So I have a saver, type loader. And the reason you do this is then you can define what the method is supposed to do. And you have to document the interface, which was really sucky in the documentation, unfortunately. Because when you do that, you have to document the interface. So, yeah. So we do load, saver. We have getter. We have a saver. I might as well keep this. Whatever. I mean, all right. So, a reader saver, and then what you do is I'm going to say it again. You document the interface, and because you only have one in there, you can document the whole interface relatively easy because it's only got one method. Otherwise, if you have like a really involved one that's got lots of stuff in here, the only way to document it, I kid you not, is to like write comments in here, and those comments will be transferred because the internal parts of the interface will be shown in the documentation. You can do that, or you can provide a big, comment for the whole thing and then itemize the same exact names, but that removes the documentation from where the code would be. If you break, it's another byproduct of having really simple interfaces, is now I can document that interface, and I can say in very specific terms, if you are going to fulfill conf.setter, this is what you must do. Not just what you have to pass in, but how it has to behave, what the expected behavior is. And then you're doing code by contract, right? You're doing some of these techniques that have been around forever so that people can look at your set of interfaces and then get a sense of what that's going to do no matter what. And if they want to port it or they want to subclass it, it's not subclass, but they can get a sense of it. So I'm going to leave raw there. That just exposes the internal, and that's very specific to the struct. So I don't feel like that needs to be an interface. So, and then we have a loader. So I don't know what the loader is going to do. So what does the loader do? The loader loads, and we're gonna use load. We're just gonna do an error. So save and load these are using the internal values. This is the real strength of this module is it does a lot of implicit magic to find out what it's going to load. I have a problem though. What my problem? Where's my problem? I delete something. Line 19. Type reader. Oh, right. Type reader interface. So interfaces are kind of magical and scary to beginners, but once you get on them, all they really are is sort of points in a contract. They're that you promise to fulfill if you do this thing, right? These are the things that's going to be passed in. This is what's going to come out. And if you go the extra mile, you should write the description of what anything that fulfills this interface must do. So like the stringer from FMT, it says you must return a string. That's it. We don't care how you get that string, but that string must come out. And that string, you must know that string will always be used in the following situations in the following ways within Go. So that's the way that goes. What else we got? We've got. So it's a little involved, but I don't know. I'm going to keep it. There's really strong opinions on this whole minimal interface thing, but I tell you right now, if you want to know Rob Pike's opinion, you should never have more than a single method in an interface. He's such a big proponent of that. He goes off on that all the time. I mean, he makes exceptions and stuff, but that's a big deal. And then if you want this interface, which is, a composite of all the other ones, then it's like, okay, if you want to make a 100% compatible plugin, thing. So instead of rdbxrob/conf, you want to have your thing /conf. You can make your own version of a map. You can add more methods to your map, right? As long as it fulfills these things, it can still be passed in. So let's say you don't like what I've done. Like you don't like that I only have JSON. You want to put YAML on yours, right? Rather than, inheriting stuff, you make your own. You make your own version, your.conf or whatever map. Actually, it would be conf.map, right? So you fulfill the conf.map, so your.map, and then you add YAML JSON or JSON output or something like that. Oh, you're giving me the rest?
Yeah.
Oh, you're the greatest. I haven't been drinking it, but oh my God, I'm going to be jumping off the walls. All right. The reason you do it as an interface is so that you let other people do it. If I had passed in a struct, you're fucked. Passing a struct, you're fucked. You're fucked. Passing a struct, you're fucked. There's a limerick in there somewhere. Because why? Because now you can't say, you know what? I want my map to have YAML stuff in it. I want my map to do X and Y. I want it to have more sorting. I want it to have all this stuff. You can't extend it because you would have to make your own version of the struct. And if you pass it in, because I'm accepting a struct, it has to only be that struct. You'd have to extend the whole library and change it. So seriously, people, really consider passing interfaces instead, particularly in user space, userland, rather than structs, because this allows you to have that multiple. Now, there are certain cases where it doesn't make sense. So usually it's internal though, because why? Because if you're passing an interface, you're automatically forcing people to do function calls. And I personally believe that I am the guy that gets overly discombobulated over passing performance, right? Because when you use an interface, you automatically force people to do reads and writes. The end. They have to do function calls. They have to do method calls, right, to get to anything. That's the nature of an interface. And even so, like one of the standard ones is in the file system. This is probably the most standard one in Golang that does this. It kind of freaks me out every time. So, reading file I/O and reading inode information and stuff like that is a pretty common thing in Go to do, right? So, here we go, right? So this is returning strings and stuff. This is path. This is the path. I'm using the path library. I think the one I want is actually I/O. No, is it file or? Yeah, it's file. Yeah, I think it's file. They got rid of a bunch of them. But did you know IO utils deprecated? Never use it again. IO utils. Anybody within the sound of my voice who's read a document that suggests to use IO util is dead. It's 100% dead. It's been deprecated. It'll be around forever for backward compatibility, but it's no longer supported. It's either OS or IO now. So a lot of people don't know that. So make sure, and if you're going to do Go programming, you should probably read the blog, the release blog every once in a while. See, there we go. In this post, we're going to look at how to write files. Go has the IO util package. Even this is wrong. This is Go's own blog, and it's completely dead wrong. You should never use IO util package anymore. It's been 100% deprecated. So, no, this is completely wrong. I'm not going to show that to you anymore. It just goes to show how hard it is to keep up. All right, so Golang file open. How to open a file in Go. So I'm trying to show you a case where there's something, for file, file stats. It's actually the file info is the interface. Yeah, getting file info Go. And I'm trying to find the standard package so I can show you. I just want to give you an example of it. Here we go. OS. Yes. Okay. So the OS package, the standard package, OS standard package, is designed for cross-platform compatibility. So anytime you see anything in the OS package, you know immediately it's safe to use for any possible supported architecture and operating system. If you use something in syscall or Unix, or there's lots of other places, they're only going to work on that operating system. So you're safe if you use things in OS. And the reason I'm telling you that is because one of the ways they got around the many different ways that people store file information, in Unix, of course, it's, inodes, is they created the file info interface, right? So this is a file info. So, and it gets returned a lot. So if you're iterating over a directory, let's say you're iterating over a directory and you're looking at all the stuff in the directory and you're like, I've got this file. This is, this is awesome. But you need to get to this stuff. And so it returns, it's interesting because they moved it to FS. I forgot they did that. The files, I cannot wait to tell you about the file system package in Go. It is so brilliant. It is so brilliant. It's how they implemented the embedded file system that can be stored within your own binary as well. It's just so totally cool. So here we go. So we have the FS. Yeah, I got to go find file info. Yeah, they moved it. Okay, so this is the file info. Now, why did I show you this? Because I just went off on how come Rob Pike and everybody say you should only have one. I have not heard about Rob Pike's UPS pin project. It sounds really cool. Yeah, anything the guy does is just almost always genius. So, no, it's not all my Z shell. I would never touch that. This is Bash and Tmux with minor customizations. Don't use Z shell. The end. Friends don't let friends use Z shell. But I can't tab the complete. Yes, you can. You just don't know how yet. Keep reading, you'll find it. Fucking do it. Toppling is really excited about this project. He wants me to look at. I'll probably look at it later. Okay, so the point I'm making. What's the point I'm making? You don't need Z shell. You can install Bash. It's like one brew command to install Bash and use Bash. Not an excuse. All right, file info interface. I'm showing you this because after all that stuff I just said about single method interfaces, which is the best practice, overwhelmingly, there are definitely exceptions to the rule, and they sort of make me uncomfortable sometimes because there's all these method calls which return things that could be, could slow things down. Now, and that's what I'm talking about. That's an irrational fear on my part because it's a method call doesn't mean it's going to be slower than looking up an instruct. I mean, if it is, it's like so tiny, but they call it indirection. So I'm like really averse to indirection. Indirection is when you do anything that removes you 1 or 5 or 10 steps from where you can get the data. And so interfaces, by their very nature, force one level of indirection for the sake of flexibility, right? So for the sake of flexibility, they force one level of indirection, meaning you have to have a function call. And so for me that is a little bit tough. Um, yeah. We're not going to talk about that. But they're going off on Z Shell on Mac. And I was like, oh, okay. So, file info interface. You see this? So they have a name, size, mode time, is directory, assist. This information, I love that they have sys as kind of a punt, right? They have an untyped interface, which is the raw data. And the reason they do this is because this has got to work everywhere. It's got to work on every possible operating system. And if you look, it's pretty much the same stuff that comes from an inode, right? If you know inodes at all, if you've ever done that, you look at the C struct for an inode, it's pretty close. And so they return all of these, right? They don't have a namer and a sizer and stuff like that. So this is a case. This is the file info one is a good example of in order to provide universal access to stuff that would normally be in a struct, but they can't guarantee is always going to be there in a particular way. They add that one layer of abstraction on top of the actual data, the struct data. And this sometimes rubs me the wrong way because it's a function call and it seems unnecessary to do a function call. I could just go straight to the struct, right? If I was writing it in C, if I'd open an inode, I'd have the C struct, I'd go straight to it. But then it would only work on C. So another reason to have that would be this, right? And I guess I probably should say before I keep going here that when I do this, when I have all of these interfaces here, this does not, because I have these one method interfaces, that does not add an extra level of indirection, right? This composition is just a compiler thing. So there's no extra performance hit for doing one level interfaces, one method interfaces, and then combining them into a bigger interface. So yeah. All right, so we're going to go on. We're going to continue with this. And so you have the saver and a loader. I have some errors still. Let me go find them. I have type reader interface, reader error. Is this from interface? Let's see, 19, expected type, found, comma. I must be missing, it looks like I'm missing a parenthesis somewhere. It looks like I'm missing a parameter. And while we're at it, if you don't know about interfaces, and the untyped interface is a type. So, yeah. And so here we go. Thanks for all the help. People are helping them. I'm going to document that. Black mouse, I'm going to definitely document that. Not to switch, not switch shelter. Okay. Z shell key, val, string, error, what do we got? I don't know where that error is coming from. I don't know. I'm going to try again. Yep. Line 19, column 3. And the other thing about Go is it's so precise in its errors. See over here? It tells you your exact position. So I can go to 13, reader, type. Oh, yeah. Why do I have parentheses? Stupid. Stupido. Yeah. I would never use Mac. If I had a Mac, I would use Minikube for everything because I want Linux. I don't want some bastardized version of BSD. But there's lots of people who disagree. So have fun. How's it going, Joppy? All right, so we have, what do we have here? We've got, I hope you have your own music on if you want music. I've left music off today so I can focus. Mac is fine compared to Windows. Amen. Amen. Yep. But the Windows isn't bad these days. Not horrible. Linux is better. You can use Linux on all of them because containers. So I don't get it. Including graphics. Let's go software and battery life. Yep. Battery life makes sense, Matt. That makes Matt Dan's talking. Yeah, that makes total sense. Plus, look, if you're going to have a I watch movies on my Mac because it's a superior device for that kind of thing, for sound engineering and for music and stuff. And I love sound engineering stuff. Yeah, Mac is a superior device, no doubt. I'm not going to put down anybody for their choice of OS or for their choice of like host computer. I just when people don't run Linux on their Mac, I'm like, why are you not doing that? Because it's really easy. It's like install the VirtualBox, install Minikube, boom, you've got a Linux terminal. Sup, dudes? Jonestown. Your name still gets me every time. All right, so we got all these things. I need to implement the saver interface and the loader. This is also the opportunity for us to say what it does. Let's say getter interface. I wonder if there's a standard for this for documenting it. I wonder if there's a standard for that. I'm gonna look this up. I'm gonna look this up. Apologize for this. I'm gonna do it the old-fashioned way. I'm trying to look, I want to look for the documentation for the interface, for the stringer interface, to see if they have documentation conventions for stuff. Normally, for example, when you're documenting methods, you're supposed to begin with the method name. When you're documenting a package, you're supposed to begin with the package blah. There's like I don't even remember where I read them, but there are some very standard ways to document stuff. And I want to read about the stringer to see, because it's a pretty simple one. Okay, here we go. The Go stringer is implemented by, see that? They always start with the type. Yeah, this is Go doc. Yeah. Method package name and its doc string. It can be your opinion. It doesn't matter. This is the standard. That's, yeah. I mean, go read it. I'm telling you. I mean, you might not want to do it, but that's the standard. So, it's hard because you sometimes want to avoid the repetition of the verbs, like get, gets. You know, that's not anywhere. That's not mentioned anywhere. That's not a standard. It's a convention. I should probably say that better. Yeah, I don't like it either. But you know, the one thing about Go that's really good is there's lots of conventions and standards and idioms and stuff. So, you know, they take a lot of the energy out of having to rethink it every time. Yep, stringer is implemented. So it seems like all of this documentation begins with stringer is implemented. So I'm going to go ahead and do that. I'm going to say getter is implemented by anything with a string value to return. That's it. Setter is implemented, and I want to do this because I don't want to get zero documentation and get dinged for not having docs. Tmux pop os bash, yes. Setter is implemented by anything with that takes a string value with a string key. Any valid string data is allowed as the key, including including periods, dashes, brackets, even emojis. All right, so this is what we're doing here. Your getter is supposed to be generic interface? No, God, no. This isn't a generic interface. This isn't a generic interface. I don't know what you're talking about. This is an actual interface. It sounds like you're confused about the empty interface type, which is a type. It's a specific type, just like an int, and an actual interface. You wouldn't be the first. No generics. No, we're using interfaces. We're using just plain old interfaces like Java and C++ and everything else. So we're just defining an interface. Why isn't it string getter? Because It doesn't need to be string getter. Why would you put the type in the name? That's dumb. No. No, the scope, the zeroing in on the scope is defined by the package itself. So if you're using a conf.getter, you're using a string getter by definition. And if you want to know about it, you can go read it. I would never put types in my interface names. I think that's stupid. Yeah, exactly. Yeah, Black Mouse answered the same thing. Exactly. Black Mouse literally said the same thing as me. Thank you for that. Reader. Okay, so reader is implemented by anything that takes an io.reader and reads from it, returning any error in the process. I mean, it's basic stuff. I know this is generic, but I have to. Some of these are going to have more interesting explanations. So saver is implemented. I think that save. Okay, so this one I have to actually say what it's going to do, right? Let's see. And then that takes out a reader and reads it from the data process. Okay, so this is where I get to specify the standard. Okay, so the data being read must comply with the requirements for configuration data, and so I'm going to put that here. I'm going to specify the standard here, so that everybody knows if you're using one of my readers, this is what it has to do. Each one configuration per line. This is why I'm writing the docs early, but I don't care. Configuration per line. Line must contain an equal sign. Delimiter. Data must not. Let's see. Data must not contain empty lines. If it does, it'll. I don't want to skip them. I'm just gonna because it's gonna throw them out. It has to be able to rewrite. Must not contain empty lines or comments. There's no such thing as a comment in here. I want this to be wicked fast to parse, so we're not going to allow any of that stuff. It'll be readable much more than JSON, but it's not going to be, and you can even edit it, but there's some strict stuff. Lines may be ended with Go supported line returns. How about that? That's all I'm going to say. So I want to be able to write the specification so I can implement this in C as well, because I'm going to use C. I'm going to write some C code too that reads the same configuration format. Yeah. So lines must be ended with Go supported line returns. Data must not contain empty lines or comments. One configuration key equals value pair per line. Lines must contain equal sided delimiters. Values, keys and values may be any string except what? Maybe any string value except line endings, except line endings. Okay. Lines must be ended with any supported go line ending. And I think that includes /r/n. No, because escape sequences don't trigger. This should put it in our tests. We're going to put it in our tests in our loader because we need to be able to check every single value. Whatever read line does, let's go look. Golang. No, those are all fine. You can put those in. I don't care. Anything but a line delimiter. That's I don't care about anything else. So, line ending. This is the difference between what I'm doing because I am not going to do any escaping at all because it takes away. It's processing stuff. Read a file line by line. So we're going to do file read line. Here it is. There is, scanner, right? Buff scanner, scan line. There's a line scanner here. This is the standard way to read a line. You can use scanner and then say scan for lines. And, yep, scanner print line log fatal. So we're going to do next. What is it? New file, optionally use scanner resize. Where is it? There it is. Scanner.scan. Scanner.txt. So we want to look what the scanner.scan method does, and I don't remember. I'm going to just reread it. Scanner. I mean, most people will never go through this amount of work for this little utility, but I want it to be used everywhere, and so I want it to be 100% clear what it's doing. I don't want there to be any, wiggle room for people to write shit that get mad at me for later. So scanner.scan. So we have the reason I'm looking at this is I want to see what scanner.scan does in terms of I want to see if it uses the standard line returns, which are carriage return, line return, or just carriage return. Those are the three standard line enders. There's actually another Unicode line ending that's been supported by some things. And so I want to be able to describe exactly what is going to be scanned. So scanner.scan, here is the method implementation. This returns the position and everything. Example, scanner.scan, the section is empty. So here we go. This is why it's like, so scanner.scan scans the next token and returns the token position. The token is literal. If the return token is a literal, I think I have to actually look at the other thing. Yeah, I think I have to look at, I think I have to look at what type of scanner. And there's a text scanner. Yeah. Token semicolon, return token, no. No, that's not it. A little, semicolon returns sort of the new. Scan returns an empty literal string. There are some illegal things that can be scanned and it'll return illegal if it does that. If the return token is token illegal, the literal string is the offending character. In all other cases, scan returns an empty literal string. For more tolerant parsing, scan will return a valid token possible. So the scanner is used for lines and for regular scanning. For like when you do parsing like files, and they have a version of this that actually does the Go parsing. S.scan. I love scanning because scanning is a lot like what you would do in scanning is what you would do in C. You would do it in C. It's kind of the same thing. It is like readline. Scanning is using the scanner is the standard way to do it now, though. So it's been that way for a long time. I actually have a snippet on this particular one. Oh, that's it. It's buff.io scanner. So we want to look up the implementation of this. So buff.io, new scanner, returns something that implements the scanner interface. Again, you got to know interfaces, right? So we have to go look up this Golang this, and I'm kind of rubber ducking this more than usual because I got people watching. But normally I wouldn't get this detailed on stuff. I would just do it. But it doesn't hurt. So here we go. We have lots of different functions and stuff. So we have buff.io new scanner, right? Type scanner, new scanner, returns. So that means, okay, this is another thing. So the documentation automatically, if you have a function that just returns a type, it gets in the documentation, it gets grouped with the type, which is great because if you have a constructor, it kind of goes with it automatically, even though strictly speaking, it doesn't have a method, right? So we're going to go look at this. So new scanner added in Go 1.1. New scanner returns new scanner from read to read from R. The split function defaults to scan lines. All right, so now we got something else to look for. Scan lines is the thing that splits the lines and gives us our token, in this case a line. So split, I need to find scan lines. There it is. Scan lines. All right, so scan lines is a split function for a scanner that returns each line of text, stripped of any trailing end of line marker. The return line may be empty. Well, we're gonna prevent that. I mean, if there's an empty line, it'll be ignored. Let's do that. If there's an empty line, it'll be ignored. It'll just be skipped, and it'll be overwritten the next time there's a save. So that if somebody doesn't edit and leaves a blank line, we don't want it to crash on them. Let's do that. So let's say that. So empty lines will be ignored and overwritten by save. Okay. I just want people to understand that if you leave an empty line in there, you're dead. No support for comments is planned. Yeah. All right. So, good morning, lot. It says the end of marker option. So here's exactly what I told you. This is the international standard for a line return, for accepting it. By the way, if you're doing HTTP, the formal specification as defined by RFC, whatever the fuck, is carriage return, line return for any TCP/IP HTTP transactions. And people do that. They fuck that up all the time, and they only send \n. And web servers and Nginx and stuff like that are kind of tolerant of it. They're doing, even though this specification is thou shalt always put Control R, Control N at the end of it. So don't think that you're not going to have to deal with Control R at some point in your career. If you're writing TCP code that's dealing anything with HTTP, you're going to have to parse this. And so it's good that you have, standard, that usually you're not going to be parsing binary, data at that level. Usually not doing that. But if you're using scan lines, you know that it's already been taken care of for you, right? So we're only this is what we're gonna care about. Return line may be empty. End of line marker is optional carriage return followed by one mandatory new line. In regular expression notation, it would be this: the last non-empty line of input will be returned even if it has no new line. I'm actually going to steal that and put it in here. So per line must contain line. Each line must contain an equal sign delimiter. Each line must end in an optional carriage return and line feed. Lines must end with blah. That's all. They'll know what that is. Must accept lines and keys and values may maybe any string value, except line endings. Lines must end with blah. Keys and values may be any string value except line ending. Obviously, that means that you can include escape characters. I don't care. It's a bad idea. But you can do emojis. You can do anything. It doesn't matter. It can be binary data even. It doesn't matter. I'm going to put editable string keys and values is strongly recommended, but it's not required. So because the edit command, we're going to have editable, right? Let's add that. Let's add editable. We don't have that yet. Loader. That's actually a big one. Editable. And this is, we're going to say edit. Yep. And all edit is going to do is fire off an editor. That's it. And come back. Packet injection. There's no packet injection here. No, dude. The line scanner is going to be fine because it already senses that. The scanner just reads it as byte data. It doesn't ever touch memory other than that. So, no, you'd have to. No. I mean, you could probably no. It wouldn't work. I mean, it would be interesting to see if you can make that happen, Jalop. Let me know. I see your point though, because if we had, I mean, you could probably fuck with it by putting like a null value in there or something. But no, I think it'd be fine. Anything else? If I do anything else, I have to check it. I don't want to do that. I have to gatekeep like every single character that gets approved, and I'm not doing that. That's like really slow. I'm not slowing it down that bad. Edit. Error. All right. So, and we'll put editable down here. Yeah. I mean, there's one way that I think it could be hacked. I mean, first of all, you're the one in control of the configuration files that's getting written there, right? So if you're using tainted data from an external source, you're already fucked. You should never do that. I'm not doing the check in this tool. That's a check you should do. If you want to do it, fine. But then if you open up with an editor, so let's say we put some binary data in there and there was a bug in VI, which there isn't, but if there was, or Vim or whatever, and then you run the edit thing later on the file, then the editor would get to the line. It would process it as executable code. It's not. It doesn't do that though. So it just keeps it. It's just raw data. Yeah. So I think that's gonna be fine. If you need more than that, this is why I'm writing this, right? Because if I didn't write this contract about what's exactly happening in here, that it accepts binary data, even though it's a really bad idea, you might not know to put those safeguards in. You might make an assumption about what I'm doing here. I'm not. This is all I'm doing. I'm just parsing this, and it can be done in C, blah, blah, blah. Okay, so that's why I'm spending so much time writing this out, particularly since this is, going to be a module that I might want others to use. Editable string keys and values are strongly recommended. All right, so if I do any validation of the data, I lose my ability to just split the string on equal. And that's super important. And I'm going to put here white space surrounding equal delim will be included in key or value. Will be included, yeah. I'm going to say around key delim is not, how about that? Is not ignored. So that'll be part of the key if you do it. I just wanted you to know that. This is not JSON. It's also not properties file. The key value is not ignored. Each line must contain an equal sign. Okay. I want it to be consistent because I want to be able to bash script this shit and do it like, I mean, I could do it easy with bash as well, but it's also going to be easier to code in C, and I want to actually use this to help people learn how to code C. What do we got here? Keys and values. So we got the reader interface, the saver, the loader. Saver is implemented by anything that saves to a default or inferred location. So in the case of this, it would be, what we're doing. Actually, no, because it's a conf saver, we could say it must save to the default, or I could put the rules about where it's going to save it, rather than writing them about over the save function itself. Yeah, let's do that. I mean, there's lots going on here, but let's actually do the save. I like this. It's coming along well. All right, so I need to stand up for a bit. I'm going to take a 5-minute break. I'll be back. All right, so let's go back at it. I'm just reminded when I was taking a break. I was like, I did this whole thing in Bash in an hour, less than an hour. You gotta put the time in to do it right, and this is why it's so important. I think that people don't start with a final form because you're going to be making all kinds of adjustments as you go to how you do the thing, and you want to do all of that up front. And then Bash is perfect for that because you can just Perl even, because you can alter it and change it and get it to just work, and then you can go down the path of writing the real solid version of it. I mean, why would I make an interface in Bash? I don't know. It's useless, right? So why would I even write documentation about what the lines are gonna be, right? But this stuff all has to happen if you're gonna have production quality code at some point. The unfortunate fact is that people don't usually get to this point. They just they stick with the Bash or the Python that they had, and they never go beyond. And a lot of people argue that Python is good for that because you can actually add or TypeScript or something. You can add that level of formality to it as you go, and then just kind of build on what you already had. And I don't particularly agree with that. You definitely have to have something that's strongly typed. All right, so I don't know if I need to document all these right now. I will come back and do them. But it did make me think of some of the other stuff that needs to be here, which means I have to implement all of these things. And otherwise which means if I don't, watch, I'll show you. So we got our scan lines in. I don't need a reader interface anymore. So let's turn on some testing, and it'll. Whoa, that was weird. That was really weird. Why did it pass? It didn't implement the interface, so it shouldn't have passed. Because I didn't make anything. That's why. Or did I? No, I did. I shouldn't have compiled. Unless I've got all my stuff here already. I might do have that already. JSON print edit keys. That's weird. It should not have done that. It should not have passed because I didn't implement the editable interface. Oh, you know why it's doing it? I remember. we did all the definition of the interface, and we never told anything that it was accepting one of those interfaces. Yeah, there's nothing. It's making a new struct, and the struct fulfills the interface, but we don't do anything that causes it to test whether it's being fulfilled as an interface. So to do that, we would have to write a function that passes. I mean, we could do that. That's probably a good. That's probably a good. Probably a good little test here. So this is a localized test. So nobody's gonna see this. So different convention here. We're gonna say. I guess we could call it interface check. Let's do map struct. Map struct. T testing.t standard stuff. And so we need to define an inline function and pass it. So let's do this. So if we do, all right, so let's not inline an anonymous function. Let's say, I don't know, f equals func, and this function is going to take what do we call it? A map struct, and it's going to return. It's just going to empty. It doesn't really have to do anything. We can just return 1, and it takes. No, we can just return. It doesn't need anything. It just needs to say it takes a map struct. So let's say as I didn't do anything with the argument, but we don't care. Why? Because now I'm going to do f dot. I'm going to call it. Actually, that alone should trigger a problem. Yeah. Watch. Yeah, let's try this. So if I do, yep, that should probably value not use func literal. Oh, I can't find. F equals. How about this? Yeah. No new values less. Yeah, I know. Fine. So you're gonna make me call it, aren't you? Okay. F dot. I just have to call F. All right. That's probably enough. Have abstract. There. See? Oh. We're gonna pass some abstract. So let's just pass. Yeah, I don't know. I don't know if it's gonna work. I'm trying to force it to do the normal fail that it'll do when you try to use something that doesn't fulfill the interface. You normally get that when you only get it when you're passing stuff. It's weird, so it's a little bit hard to test for. So uh um I mean, I could do this. I could say m equals a new map struct. Is that what we called it? I don't remember. And m undefined new map struct. Yeah, I don't remember what it's called. I'm gonna have to look. I mean, this is probably more than is needed, but where is it? What do we call it? They say conf.newMap. Yeah, because it fulfills the interface, so we can still say new map instead of map struct. I could say test new. I said test map. Yeah. Actually, we could do test new map. This should do it, but it's not doing. It's not doing it. I don't know why. It should be okay. There we go. Can I use the map struct? Fine. No, we have to take this. Okay. All right, we want to take a map. There. See that? That's exactly the error I wanted to trigger. See, it says map struct does not implement map, missing an edit method. You only get that error when you try to use your interface in a way that doesn't fully implement it. So that is something you kind of have to trigger, right? It won't even compile. That's what I'm trying to tell you. So and if we get here, it passes, right? This is why I did it as a localized test, because it's really confusing. This is the only reason I'm doing this, is to check whether I fulfill the interface or not. And I didn't, and that's what I was expecting. And I was like, why did that work? And then it shouldn't work. So I need to go down here and implement, even it's add a hook for map struct, and give it a edit, return an error. If I have edit without returning an error, it won't fulfill it. Watch. So if I have that, it'll fail. It's just like you have this, right? So it has to actually be the right, it's got to be the right thing. It's got to map the function signature perfectly, including the return. And then it will fulfill the interface, and we should get another error at that point, load. So see, this is what I'm talking about. This is why I did this test. This test is it's forcing some fails that normally happen during build time, that check your types. And so that's what I'm doing. I haven't used my thing anywhere, so I put using it in the test so I can get the stuff to fail early before I start using it someplace else, and I can fix all the stuff that's not working. So load, I forgot to return error. All right, so we'll do that here. Error. Read probably has to have an error as well. It's pretty standard to do that. If I'm not doing it, I need to. So there we go. Missing return to ended function. These are the normal things. So I need to return nil on all of my stubs. This is gonna hand off to your editor environment variable. It's gonna call it and open it. This is all done, so that should be done. There, we pass again. See? So that was interesting. That was interesting because I've worked with interfaces for a long time. At least it's not like forgetting a semicolon. Yeah. So we need to now we need to implement the rest of the stuff, and we know what we need to implement. I feel like this is a commit moment because I've got the interface defined. I've got the loader and the saver, and I have exactly what it's going to do. Actually, I'm going to write up the rest of the documentation for the interfaces, and then I'll commit that, because then I know what I'm building, right? So readers implement anything that takes the IO reader and reads it from it and return the process. The data being read must comply with the requirements for config data. One configuration key value per line. White space around equals delimiter is not ignored. Each line must contain an equal sign delimiter. Lines must end with standard line endings with let's see. Scan line endings. So I'll put that here. Keys and values may be any string value except line ending. Editable string keys and values are strongly recommended. Empty lines will be ignored and overwritten by save. No support for no support for comments. Okay. That's it. All right, so that's a reader. That's what we want to read. That defines the example. I should probably give an example. You guys aren't going to like this, but this is part of coding. So, and I could actually give an example of this interface, of the reader interface. I can actually do that by writing an example type for that. That's probably the better way to do that. I don't know what that'll look like in Go Docs. We need to go look. So actually, let's look at some docs first. So if you want to look at what the documentation is going to look like, how's it going? You can do godoc-all. And it will show you the documentation that you're going to end up getting rendered. You can do this fancier. You can put it on the web if you want. In fact, I think godoc-h. I think it's -web, and it'll give it to you. Short one reception symbol source. I can't remember it. There's definitely a Go doc to generate the HTML, but I don't remember how to do it. I don't ever do it. So this is the documentation of the thing I've been writing. And so it tells you I got my functions, exe returns a blah. It's using 80 characters. I have 79 because my 16 by 9 won't do it. What else? So it tells me exe file returns a path, home does that. It gives you your types. So here's my interfaces, getter, setter. It tells you a getter is implementing anything with the string value to return. Loader, blah, blah, blah. And my new map, that's interesting. It didn't do all my interfaces. It didn't do all my interfaces. I must have a problem with one of them. It didn't do my setter interface. It didn't document it. Why not? Do I not have it? I have it in my setter interface. It didn't get documented. Maybe. I'm not sure. That is weird. I'm confused. You see this? Multiline? No, it'll do multiline for sure. I know that. Oh, it's alphabetical. It's down below. I'm sorry. M N. Yeah, it's gonna be under the S. Yeah, here we go. See. So, yeah, set. There it is. Now that's the struct. Set sets the value of the key to value string. Warning: use a line return will break. See, I need to get rid of that documentation. This is one of the most frustrating things about Go. I'm about to show, and you guys know I love it, but there's a couple of really frustrating things about Go when it comes to documentation. If you use interfaces, you have to make a decision about where you document it, because this documentation is for this implementation of the interface. And so what you end up with is shit like this, and I don't like it. It's all over in the standard library, but there's really no better way to do it. So this is the documentation for the interface, which I'm not seeing for some reason. I got to figure that out. And then you have, pardon me, you have the documentation for this, right? And this is for the specific implementation of that interface for this struct. And this is in addition to that. So um, and we should, so, so what? So that warning is important warning. It should probably not go there, right? It should probably go here. But this is, so when you do interfaces, this is frustrating as hell. When you do interfaces, it because you're defining generic behavior for the whole thing, then the documentation for the implementation only needs to say what it does differently from the normal interface. Like it might say, this is how I implement the interface. But the interface documentation is like, this is what's required of anything that implements this interface. And then, so when you're writing documentation and you're using interfaces and you're writing interfaces at the same time that you're writing the struct code, you have to make decisions about where to put the doc. And I guarantee you that most Go programmers do not belabor this point as much as I am. They normally just do the thing and they don't care. Struct methods interfaces don't know. Yeah. So any valid string data is allowed in the key, including blah, blah, blah. Okay. Sets the value, sets the value of key to the string. Warning: use of line returns will not be escaped automatically, and will break the save. Will break other methods that depend on scan line endings. So this is, strictly speaking, you can use this interface without using it in my package, and this is to preserve performance of a single character. So any additional, all right, so my line return editors, okay, freaking out. There we go. And so this needs its own paragraph. Yep. That's, you see what I did there? That's a trick for formatting in Go. If you're going to use Vimgo, is you get on the line and you do your GW or whatever. There's different variations, and then you go up. So then in my case, I think I have to look at my keys, but so that's like that bracket, right? It goes up. And then if you don't do that, you do this. If you try to just do a regular GW and go down, it'll do that. And if you have a multi-line, that'll break it in ways that can't be fixed by the auto formatter. So usually it's better to, you can also do it just by being in here. And I think there's in comment fix that's a VI specific, it's a Vimgo specific thing. Otherwise, my traditional way is just go down here, GW that, and go up, and then it formats the Go doc. So I mean, that's a lot to say about that, but all right, let's see what that actually changed. I don't know if it changed anything. We're going to see. So functions: exe file, home. Types: we have an editable getter. Getter isn't implemented by anything. We have loader, map, map struct, and then it's going to document the whole struct. Here we go. Has unexported fields. So that means it's got internal stuff. And you'll notice there's no documentation for that struct at all. We've made the struct public. So the question then becomes, do we make it? And actually, I'm going to answer that question right now. I've been wanting to test whether I make this private or not. And this is something I've been spent on my mind, so I want to figure this out. I don't like public structs at all. And I at first, a long time ago when I was coding Go, I thought you could not return a private struct. You absolutely can. So I'm going to test this actually. I'm going to make them all private. So this is not what I'm doing right now is not a convention that it's not. It looks like a Python thing to make it private. It's just because it's not a capital. Doesn't start with a capital. But I'm going to do this to everything. I want to make sure I get the right ones. I don't want to script documentation and stuff. Some people would argue this is a time when an IDE is better than Vim. Probably true. Or what is there's a C mapper thing. I can't forget what it's called. It does just all your identifier names, so you can just change them all at once. But that's fine for me. And so why did I do that? Because I want to see what these docs look like. And I think it shows the type, the private type of the return value, but it lists it as something else, right? Reader interface, saver. Where's the new? Oh my God, I didn't even do it. That's amazing. It's totally private. See there you go. See this right here? See that? And that's why this name matters. I was afraid of that. This name is going to show up in your docs, right? So when you document new map, you have to say returns a map interface. The problem is that you want to return the struct anyway. I got so fucking burned by this. I just cannot tell you, okay? Pass interfaces return structs. Even if the struct is a perfect implementation of an interface, don't return the interface. Why? Because everybody from that point on who uses your thing has to use only the interface methods. They can't use any of the internal knowledge of it, even if it's in your own code. That is a pain in the ass. It's a pain in the ass. It's one of the biggest pains in the ass. And you think you're doing the right thing because you've been told to use interfaces, right? You've been told to use interfaces because it makes your code flexible and stuff. Not if you return them. If you return an interface, you want to return, yeah. You absolutely know what I'm talking about, Black Mouse. And the second you have to cast it, Black Mouse is using an example here on Twitch. I would love to show you, but the second, because now you're already you're dealing with all your internal, and reflex as well. So you're dealing with all this internal stuff, right? And you should have access. You should have access to be able to use your stuff however you want inside of your own package, right? So you should be free to make assumptions about the internal structures of the things that implement those interfaces that you're passing around, right? You should be able to do that. That's a part of your overall implementation of the thing. And that's why it has to be a struct. So even if it fulfills, it's designed to fulfill one interface explicitly and perfectly for everybody who's going to use it, you really need to return the struct. Don't return the interface type. Both of them are possible. You can return both. But if you do, it will lock you down and slow all of your other development. That's a very bad anti-pattern. But everybody falls into it. Everybody falls into that anti-pattern. I'm telling you, they do it all the time. So, I know I did. And I struggled with it really hard when I wrote my parser. I don't know if you guys saw it, but there's video of me somewhere writing my parser a long time ago. And I was like trying to do the right thing and use interfaces. And then I did the opposite. I punted and I made everything a struct, which is equally as bad because now nobody can extend my interface because my code because they can't pass in interfaces. So you dropped the idea of the whole thing? Yeah. And so then this is, you wrote recursive reflection. And then useful stuff instead of just printing. Yes, I know, and you don't catch it. It's one of the gotchas. This actually is the Learning Go book from O'Reilly. Who's it wrote it? I forget the author's name. They cover this, but the rule is pass interfaces return structs unless you have a really strong exceptional path to do that. However, that does leave you with an interesting quandary, right? Because in your documentation, there's going to be this really weird reference to a private thing. And everybody's going to look around in your docs and be like, what the fuck is that thing? They have no idea what it is, right? Now, the good thing is that because it's a struct, well, first of all, it's a private struct. If it's a private struct, the private struct isn't documented anywhere. The only thing that's documented, which is great, right? The only thing that's documented is the interface. But you need to communicate in your documentation through the name of this and through the document for new map. You could say returns a struct that fulfills the map interface. And the only hint, you can make new map private. I could, but I want people to be able to make maps on their own. Yeah, I definitely could. Because you can create interface and implement it. What are you talking about? New map. No, I want them to be able to have it. I'm trying to get my head around that. So Black Mouse is saying that you can just go ahead and make new map private, and I don't see a way to do that and allow them to still use it, because I want them to be able to make their own maps, right? I want them to be able to get a copy of something that fulfills my map. This is the other dilemma. So like, if you include an interface, do you include a solid concrete structure that implements the interface as well, so that people have that utility to use it? Are you going to force them to make their own? So about books, do you recommend any C books? No, I hate modern C. I hate it. I have it right here. It sucks. I don't like. I like data structures and algorithms in C. Private stuff can implement public interfaces. Yeah, but then it wouldn't show up anywhere. They wouldn't know that they could get. I need a factory. I need someplace for them to get one. I learned with Practical C, and that's my favorite book so far. I like Head for C too for beginners, but it's a little Mickey Mouse. Some people don't like it. Everybody would tell you to learn K and RC from KR book. It's got massive flaws in it all over the place. I would not do that. It's hard because the modern C book uses stuff that's so modern that it's kind of bad practice, in my opinion. But I haven't. Again, my C is really fucking rusty. I haven't written it in a long time, so maybe it's good. As many things as you can. Which one? I learned Practical C, the old O'Reilly book. I don't think it's been updated forever. I love Practical C though, because it shows you so clearly how pointers work. It's really good. So we have this quandary here, because I can return a private thing here. I don't, as I said before another day, we don't want to expose too much, because then we have dependencies. They're going to want that to be there all the time, right? And I mean, we could have just made struct a public thing and forced them to deal with it individually, but we're already not doing that, because the internal elements of struct are not allowed to be messed with. So yeah. The reason I want to make it private is I don't want other people to make code that lists as the arguments. I mean, I want to protect myself from dummies out there who are going to make code that depends on conf.mapstruct as an argument, which they never should do. They should pass in the conf.map type. But there's dummies out there that will see the struct, and they will pass the struct in, and they'll be tied to the struct, and they won't be tied to the interface. That is a huge problem to me though, because they'll become dependent on it or stuff, and even I might do it on accident, right? So I don't want that. If they're going to become dependent on me, I want them to depend on my interfaces, not on my structs. It's a very rare exception where I want them to be dependent on my structs. It is really their problem. It is, but when you're writing code for other people. So what do I do here? Do I make this a private thing? That's actually what I'm going to do. I'm going to make it a private. I'm going to say map struct. And that should convey what the thing is, even though I make it private. And then if I do this, I don't actually have to get really, I can do a find and replace for this. Struct with map struct. We want to do that everywhere. Wait, whoopsie daisy. Oh, damn it. I do it again. Map struct / map struct. There. All right. So that's all changed. Let's make sure we didn't break anything. Let's look at the Go doc first. So now we have this nice, happy Oh, this is much better. It's much easier to read. You see why? You see it dropped all the struct stuff because it's all private now. That's exactly what I want. Remember I said I don't want to have documentation on the private. If because I made the struct private, I don't even have to fucking document it anymore. Huzzah! See this right here? I can take this documentation. I can put it on the interface, which is another reason to have single interfaces because it kind of keeps your docs clean. And I can put raw here. Where is it? Raw. I can put it over here. And do it. And then I don't have to have any documentation for my struct at all. I don't have anything because it's all private. Yeah. Everything is private. That means even the public, the implementations, the other stuff. I should probably make a JSON interface to say a JSONer. Yeah, because it influences GStringer. So go tour and effective go. Agreed. That's the best I can recommend right now. If you learn C first, at least a little, then go on it. Go to town. So actually, I'm super happy because this is, dude, that just seriously simplified my docs, like a lot. So the reader interface, thank you for that one. We have the saver, we have the setter, and then it's great. Look at how clean the docs are. They're so much cleaner because why? Because I made, so the takeaway from this is, the return, create a constructor that returns an initialized struct that's private, that implements the interface, and then in it say, hey, this returns something that does something, right? And then it'll refer them to the other documentation. I like that a lot better. So new map returns a new struct that fulfills the map interface. Boom. That's it. And now they'll go read the map interface. And this is why I think having a complex interface that's a composite of all the one-line method interfaces is totally acceptable, in my opinion. Because they can go read the whole thing, and then if they want to go dive down into each of the other individual interfaces, they can read about what those things do, and they can learn about the behavior without it, and they don't really have to give a shit about how I specifically implemented the behavior. If I were going to give details about how my implementation of map differs or from the standard or from the config, then I would put those caveats right here in the constructor, which is the first thing a user would go to read. So they would go there to read that. So that makes me happy. That fulfills the map interface. So combine. Ooh, you know what? Is there a mutex? It returns fulfills the map interface by and embeds. And so I need to be able to tell them about this. So writes it, and the person doesn't give a shit how it works. Yeah. The map interface and it embeds a sync.rw mutex. They need to know that because that's useful, right? That gives them all the information they need. It's like if it fills a map interface and it has a lock built in, boom, and they're like, oh, okay, most of the time. If they want more than that, they look at the code. Returns a new struct that fulfills the map interface and embeds the sync.rw mutex. The end. I like this because my organization is making my docs simpler, which I really, really love. So I need to put another thing here though. I need to put that this has, so now I'm going to put an implement stringer explicitly because I actually don't need to do that, but I'm going to do that. It implements stringer and JSON which is JSONer is my new one I'm going to make here. So type JSON JSON, whatever, I don't care. I think we should JSON string. No, I'm just gonna put JSONer. I don't care. Jsonify. How about that? I like it. Jsonify. Jsonify. What do we say? Jsonify implements a JSON method to return a string of valid JSON, compressed or otherwise. Compressed or indented, doesn't matter. If an error occurs, the it should be, let's see, it must be returned as the error as the error key with the message as value in invalid JSON. Okay. So I'll say, for example, I'll say error, some error message. I can actually do this on its own line. Go doc is force space indent, makes it verbatim or raw or whatever you want to call it. All right, so stringify the Jsonify. Yeah, that's what I'm doing. Jsonify. So this just has to have a JSON, and it just, if it implements it, it takes a JSON and it returns a string. That's it. So I can put stringer and Jsonify. And that, so this gives you a real, I really love this composite interface of single method interfaces. It's a thing that I like because it makes it really clear to me just looking at it what it does. And then I can go get more information here, and if I want to extend it, I can. So this is, to me, this is very idiomatic Go, and some people might disagree. Coming to Go from another language, this stuff is not apparent. I did not write Go like this 3 years ago. I wrote it like Python or JavaScript. I brought all my idioms with me, and this, breaking all the functionality out in interfaces and then do thing. This is it's a very Go way of doing things, and I don't think it's just Go though. I haven't written enough Java and C++ to know, but I have a feeling that modern Java development. I was writing Java back in the single inheritance days when interfaces were a thing. They weren't even. I don't even think they were supported. If they were, they definitely weren't pushed as a part of solid principles and all that. And it was a pain in the ass. Shit, forgot that method, right? The Go philosophy now, I like it so much because suddenly it starts making sense. I'm glad. Hopefully I can be help you see how that makes sense, right? This whole interface. This is one of the reasons I'm going so deep into this, little tiny configuration thing, is because this approach to interchangeability with the modules is very idiomatic, and it's not understood. It's not understood by people who've been coding Go for 7 years. So, how are beginners going to help walk into that world, right? Now I have to write Java at work. Yeah. But if you've been doing Java interfaces properly, you're kind of already set for this. You already know what's up, right? You know why you should do single method interfaces, et cetera, et cetera. So, I mean, this isn't a bash script anymore. This is something that is going to be reused a lot, and I want it to be solid in that sense. So, all right. I love that I don't have to document my structs anymore. I just love it. It's worth making it private just for that one thing, because I don't have to. Remember, I told you the dilemma about writing the documentation for the implementation of the interface versus documenting the interface well. Well, now I don't have to do it because it's returning a private version. The only thing I have to say is, This gives you a map. Go read about it. And a mutex. Go read about that. I love it. I love it. From a documentation perspective, that makes me very, very happy. You will see documentation where there's a public struct that's an implementation of an interface. And the documentation, this is in the standard library all over the place. And they'll say implements blah interface. Boom. That's it. That's the whole doc. Because that's the way they do it. Anyway, we still have a lot of implementation to do. I want to get this interface documented. What time is it? 11. I think our interface is done. We're going to just be the implementation probably later. I do have on the schedule at 12 or so. We're going to be doing Kubernetes work. So I'm going to be shifting gears over into Kubernetes preparation for another 3 hours or so. So that's coming up. And so I'm going to try to get to a commit point here and just finish documenting the interface, and then I'll go ahead and save that. So let's do that. So this one we have, so we have the loader. So what does the loader do? Loader is implemented. This is the way this kind of conventional way, by anything that loads from a default location, from a default or inferred location. So we need to do more docs there. See saver interface for details. And we need to write the details here. So this is really important that I need to, there's a bunch of stuff that the any saver must do. If it doesn't do it, it's not gonna be right. What's that? Your job at the beginning? Me too. Yep. Composition structures, yeah. I absolutely. I completely agree with all of your assessments. It's almost worth not reading, but you guys, if you're in Twitch, you can read it. So this I need to write up here. I'm going to put a to do in here. I need to write up the algorithm for determining the defaults. Right. So actually, I already have that algorithm. There's already functions to do it. I already wrote those functions. I could probably just refer to them. I could say, see the exe file, right? I could do that. The implied exe file values. So where's load? Yeah, let me go back and do this. Loader. It's called Scala. Yeah. Loader's implement anything. Okay. Saver. Let's see. Implement anything that defaults in for location. Which is the value returned, which must be the value returned by the exe file function in this package. It doesn't have to be called, although that specific function is not required by the interface. I mean, that's obvious, but I'm going to say it anyway. So returned by the exe file function in this package. So the exe file function returns a file from xtg config, and so this is a public function, so it does need to be documented. I need to go document it better. Yeah, I think I already did document it, but I'm going to document it again because we're about ready to be done with this. Reader exe file. So the full resolution of this will be conf.exe file. And like, well, what is that, right? I don't know if I even like the name exe file. It's kind of growing on me in a bad way. I don't like it. It implies there's an exe or something, right? I'm gonna leave it though. All right, exe returns the absolute path. So the exe file returns an absolute path to the specified file within the exe directory, within the exe configuration directory. So that cexe. So exe returns the absolute path to a subdirectory of the home config directory named after the current executable binary. Will return empty string if either home directory or current executable name cannot be determined. Okay. Absolute path to specified file. Okay, so in this case, it's going to be values. So that helps me with my documentation. Because now I can go back to, do I have something open? So no, okay. So go back to my map. There I go. Which must be the value returned by calling similar, by calling the exe function file function and passing it the values argument. See exe file for details. All right, so it doesn't have to call it, right? Calling exe file, however, is not required. Calling exe file specifically, however, is not required by this interface. This is the deal you're making with the powers that be, sort of. All right, so, all right. That seems good. All right, so saver. I think we got it. Loader, we got editable. Editable is implemented by opening the detected default, by opening a configured or default editor, user default editor set by the user. Either as a value, a configuration value, or the editor, or the editor. That's it. By opening a configured or default editor set by the user, usually as a configuration. But I don't care how they do this. Usually as a configuration value or a configuration or environment variable, such as editor or visual. Implementations will differ depending on operating system. So I'm going to put this in here so people know. There. Now, this is going to be interesting. I don't know if we're going to do this, but I feel like I don't think we need to force it to make it the last thing they do. Implementations may decide to hand off process control to the editor program, usually with exec. Not returning in a way that does not, in a way that does not return control to the calling program. Such as with Unix, Linux, exec. Please make note of such in any implementations. Because that's like worse than a panic if you're not expecting it. It's like I called edit and I lost control of my program because it handed everything over to the VI. They don't want to do that without warning them. Static typing, yeah. Static typing saves the world. I agree. I kind of agree. Yeah. So there we go. Yep, editable. I feel like that's well written. Jsonify. The Jsonify implements the JSON method to return a string of valid JSON compressor indented. If an error occurs, it must be returned as the error key with the message as value in valid JSON. If please indicate whether the JSON output will be on a compressed on a single line or not. Please document whether the JSON output will be compressed or on a single line or not. So if you're going to implement this is how you need to implement it, blah, blah, blah. I like this coding by contract stuff. I like it a lot. So raw returns inner, blah. Range storing, map struct. And I think we're good. I think I can go take a break and come back at it and do some Kubernetes this afternoon. I'm going to go have some lunch, though. So I know we're a little short today, but the rest of this stuff, the implementation of this is actually not that hard. The really cool thing about this is you can actually take this right now, and if you want to do this at home, you can go make your own implementation of this. You can swap out different implementations and play around with the whole idea of an interface and do that. So there we go. The saver loader, saver interface for details. Saver is implemented by anything that saves it. Yeah. All right. So yeah, map struct, read, write mutex. I don't want to have to write this again. That's why I'm doing this. How many times have I done it? I've done like 3 or 4 or 10 of them. This is the first one I'm doing there's no JSON in it though. And when I have this, I'm about to rip the guts out of a bunch of other programs that I have that use config. They use config-go, which is a different version of this that has JSON dependencies, including my auth script, which is really important. That's a way of like caching OAuth data and tokens and reusing them per service so that you can implement OAuth authentication within your shell scripts without incurring, static token pain. So that's one of the reasons I'm doing this. C++ by the go. So yes. Yep. Go Java. Yeah. Yeah. Well, you gotta have Python these days. My day job is all going to be Python this week because I got to do all the Jupyter Hub config, and they have Python, raw Python as their configuration. So I think we're good. Let's try this documentation thing. Try it again. Let's make sure we didn't break anything. I broke something. Undefined stringer. Oh, right. Yeah. So this is me just overstating what's already known. I didn't have to define that my map implements stringer, but I did anyway because I want to communicate it to people. fmt.stringer, right? Yep, I should probably say how it's implemented. It's an inner string for different bypasses locking or suspend range for. Yep. Oh, you know what I should do? No. FMT stringer must be implemented as, okay, this is a separate topic, so stringer must be implemented as a load saveable string. That's super important. So if somebody wants to implement this. Hi, what's conf-go? Conf-go is a configuration reader that I'm writing in Go. Okay. So editable Jsonify, editable loader, saver, getter, mapper, trigger map, raw. All right. All right, how are we gonna do this? So map implements a conf.map. Suitable for returning from new map. See the individual interface descriptions for details. Interface stringer must be implemented as a load savable string. These are caveats I got to make sure are here, or conditions, not really caveats. Stringer must be implemented as a load savable string. Raw returns the inner map string for direct manipulation, bypasses locking. The individual, see the individual single method interface descriptions for details. All right, so stringer must be implemented as blah. This might be overkill. Some might think it's overkill. I don't. I like it. All right. I'm just going to make it super flexible because it can be passed like all over the place. in the best way, because it's still going to be strictly typed, even though it's going to be really, really flexible. All right. I'm ready to save this and go eat. So I'm going to do that. Let's say add, actually, this is a git add commit. If I apply this patch, it will, this commit, it will add completed interface with documentation. Add completed map interface with documentation. So that's nice commit message. I haven't committed these. I haven't pushed these yet because there's a pretty strong dependency. I'm using master on it, and I'm afraid people are going to keep pulling it. I probably should just go ahead and push it, to tell you the truth. Why don't I do that? I don't know. Let's try it. I might break something doing this. No, I won't, because all the other Go stuff's all been checksummed. As long as I'm careful on my rebuild, I should be fine. So git push, and that should go for anybody that's dependent on my previous version of this that used JSON. So I'm using the same name and path space, GitHub path space, and that's kind of dangerous, because anybody's got dependency on it, unless they're using checksums properly or they're git mod properly. If they try to do a git update or git tidy and force it to use the new one, it will break them. They're going to have to hard code it to the previous tag, which is, by the way, why you should tag your shit. If you're not tagging stuff, you know. So this is a non-working version. I'm going to go ahead and tag it as, it's not complete, but it's kind of a working version. I don't know what to do there. I could probably do dash something. If you do that, it will actually, this is really bad. If you tag something with dash alpha or beta, Go will resolve to the thing that doesn't have the tag. Yeah. So I'm actually going to do that. I'm going to do 0.8.0 dash alpha or working. Yeah, because I want them to get that. If they're pulling it, I want them to get the other one. If they do an import, they'll get this one. If they do latest or they don't indicate their version. Although these days with 1.17 and Go, you have to indicate the version. If you're doing, you have to do go install. And you have to have :latest at the end. You don't do go get anymore. Go get. Certain methods of use of go get have been deprecated. Its basic use for getting a module that's already been installed or updating it is still there, but this whole thing where people put go get -u on their in their install docs in their readmes is completely dead. Nobody can do that anymore. You have to use go install. So I mean, this is fine. We can probably open it up now. Actually, where's my, is that it? Oh, okay. Open. Pull this down here. So this is my this is everything I just committed. If you want to follow along, this is the new version. This is another reason I want to do it, is I want to keep all these commits here. Oh, what's that about? I'm getting notifications. Apache 2.0, 100% Go, the mod test. If you want to just follow along and see what's up, you can do that. You can go play with it. I have the old JSON branches, which is a thing. I'll go look at the tags. So last.json. I did that on purpose because I want to be able to find the last actual JSON version. Verified GPG. You should do that if you haven't done it. And then I have 8-point working. This is kind of working, but it's still kind of alpha. We still have to-dos on there. I should probably change that tag. I don't care. Again, it's not a release. I'm not doing a release on that tag. Okay. And that's gonna be good. So I'm gonna come back in a few minutes. I'm actually gonna drop the stream because I'm gonna create a new stream, and it's gonna be all about Kubernetes co-learning. So if you want to stay tuned for that with me this afternoon, I'm gonna be really diving into my studies for Kubernetes again this afternoon. As I work toward certification in that, specifically with the goal of helping other people learn it, and so I can know what people think they need to know, even if you decide to not certify. Um, and that's it. That's that. That's all I'm going to say about that. It's been good to see you. I'll hang tight, and I'll be right back. Do, 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 do.